identify self-contradictions, tautologies, and implications. All right, so we have three pieces here: self-contradictions, tautologies, and implications. What do these mean, and what are we doing? Okay, so a contradiction is a statement that is always false. Always. Like, it rains every day. False. It does not rain every day. Okay, always false. Okay, so a tautology is a statement that is always true. I can't think of one right. I eat every day. True. You know how I eat a lot, right? That's a thing. Implication. An implication is a biconditional statement. So we're getting into a specific type of statement that is a tautology, always true. So a tautology is just a statement that is true, and then if we get even more specific, if it's a biconditional statement that is always true, then it is an implication. Okay, so let's just some things to remember. Oh, wait, come back. Let's go back to the contradiction. In terms of symbols, if we would talk about P and not P, okay? So think about just in terms of a truth table, P and not P. If we're talking about P being true, false, not P would be false, true. So if I'm talking about P and not P, remember that with an and I said P, but I wrote Q, P and not P. And means they both must be true. Well, true, false, false, true, these are both false. So if it's always false, that's a contradiction. Something that's always true. Well, what if I used P or not P? Okay, so now coming back up to the top here, if I'm looking at P or not P, well, or just means one of them needs to be true. True, true. Always true, tautology. Okay, that's kind of it in terms of symbols. Okay, so now let's talk about biconditionals and just conditional statements, right? So if P, then Q. So what these are conditionals. And remember that with conditionals, these are if-then statements. These are only false when the front is true, but the back is false. Front being the first piece, right? So this here is the front, this here would be the back, okay? And we will come back to this. I will refresh that as we talk through these examples. Now, when we get down here, this is a biconditional. And a biconditional is true if both have the same truth value. So what that means is two trues gives you a true and two falses give you a true. So as long as they have the exact same truth value, then it's true. It is false if this truth values differ. So if you have a false true or a true false, that's when the biconditional is false. Okay? All right, let's do an example. It's going to be kind of a big one, so just bear with me. Is the following a contradiction, a tautology, or neither? Now, we're going to see we have if P, then Q, right, the conditional, or if and only if P, if and only if R. So we have a conditional in the first statement and a biconditional in the second statement. Now, when we're thinking about a truth table, we're going to create a truth table here. I always start with a 2, and I have P, Q, and R. 2 to the third is 8. So I'm going to have 8 lines in this here truth table. Okay, so let's think through this. I'm going to have P, Q, and R. Now, if I have 8 lines, so my first one, I have to split it in half. So the first 4 are going to be true. The second 4 are going to be false. Okay, so then in the next line for Q, I go, okay, well, I went 4 and 4, so I cut that in half, and I'm going to go 2 and 2. So 2 trues, then 2 falses. 2 trues, then 2 falses. And when I go back to R, I cut it in half again. So instead of 2 by 2, I do 1 by 1. And the whole purpose is to then have 8 distinct sets of three, right? True, 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 false, true, as I read across. Okay, so now let's think through this. I'm going to do my conditional first. So if P, then Q. And remember, with a conditional, it is only false when the front is true, but the back is false. So I'm comparing P and Q, because if P, then Q. So when the front is true, but the back is false. True, true. That means this is true. True, true. That means this is true. True, false. Here it is. The front is true, but the back is false. That's where this conditional, again, true, false. Now down here, the front is always false. So we know that these are all going to be true because in a conditional, it is only false when the front is true, but the back is false. Okay, so now let's go to our biconditional. P, if and only if, R. So if they have the same truth value, P and R, then they're going to be true. If they have different truth values, then the biconditional will be false. Okay, so let's compare P and R. True, true. Those are the same. True, false. Those are different. True, true. Those are the same. True, false. Those are different. False, true. Those are different. False, false. Those are the same. False, true. Those are different. False, false. Those are the same. So that's how we get that one, right? Very exciting. Very exciting. Now that we have those done, we can put the entire piece together. My conditional, if P, then Q, or my biconditional, P, if and only if R. Okay, so remember now we are dealing with a disjunction, the or statement. Only one has to be true. So as I'm dealing with these two columns, as long as one of them is true, then the disjunction is true. So true, true, the disjunction is true. True, false, false, true, false, false. Ooh, there's a false. True, false, true, 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 false, true, true. So only one way for this to be false. And that is, so to answer the question, it's not a contradiction, because remember, a contradiction means it's always false. It's not a tautology because it's not always true, because we have this one false here, and therefore this is neither. It is not a contradiction or a tautology. So if all of these were true, then it would be a tautology. If they were all false, it would be a contradiction. But because we have a little of each, it's neither.